In today's video, we're going to be taking a look at landscape tessellation and displacement. Last week we talked about breaking up our tiling, and I was really happy with the success that we had in getting rid of all of the tiling artifacts. I also appreciated all the comments that you guys left and the ideas that you shared. It was really starting to feel like a collaboration on my channel, so thanks a lot for doing that. So what we want to do today is we want to make our landscape feel more realistic in terms of the shape of the surface. Right now we're using a normal map, and we're getting pretty good results with that. If I switch over to the buffer visualization world normal mode, you can see I've got some really nice normal information happening here, and it looks pretty good. But the landscape still is feeling pretty flat. And the reason for that is that there's no really tight surface detail. If we take a look at our wireframe, you can see that the detail here is still fairly sparse. So we need to do two things. The first thing that we need to do is split up the landscape triangles close to the camera so we have a whole lot more triangles to deal with. And the second thing that we need to do is offset the vertices depending on the height map. And so let's do both of those things. We'll start out with tessellation, or splitting up the landscape. So we're going to switch over to our landscape material that we worked on last week. And I have two input pins on my root that I want to work with. Here is the tessellation multiplier, and here is the world displacement. The tessellation multiplier pin will control how finely cut up into smaller and smaller triangles my landscape is. And then the world displacement will be the direction and amount that we want to push those triangles away from where they currently are. Okay, so the first thing that I'm going to do is select my landscape root material. And in the properties, I'm going to scroll down and come here to the tessellation section. And here it says no tessellation. I'm going to turn this to flat tessellation. And that will enable the tessellation feature so that I can use it going forward. And I'm just going to increase the size of the UI for you guys so you can see it a little bit better. Okay, the next thing that I want to do is control the amount of tessellation that I'm getting using the tessellation multiplier, and based on how far away the landscape is from the camera. So in order to do that, I need to take the camera position and I need to subtract it from the world space position. And this world space position takes into account displacement, and so I definitely don't want to do that. I need to use the absolute world position excluding material offsets. And so what this is going to do is it's going to cast a ray from the camera to the position that I'm currently rendering. And then I want to measure how long that is. So I'm going to add a vector length node. And this is going to tell me the distance from my camera to the pixel or the vertex that I'm currently rendering. And so if I take this and use it as my color, we can take a look at what this mask is going to look like. So I'm just going to plug this into base color and save it, and let's take a look at the result. Alright, so you can see that the mask is just completely white, and that's because my units are in centimeters, and so my distance from the camera to the pixel goes to 1 centimeter really fast. And so I actually need to add a divide in here so that I can bring this down to some more reasonable results. So I'm just going to go ahead and divide it by 500, which means that my distance will be from 0 to 1, between 1 and 5 meters. So that'll make the mask a little bit more reasonable. So I can save it and then jump back to my map. So now you can see if I get up really close to my terrain, and I'm just going to switch from lit to unlit so you can see what this is doing. If I get up really close to my terrain, you can see it turns black. And then as I move further away, it becomes white. So this is the mask that I'm looking for, the distance from my camera, and I'm going to use this to determine how much tessellation to do. Now there is one more thing that I want to do to my mask, and that is I want to subtract a value of 500, and this value is going to control how far away from the camera I want the mask to start. So I'm going to say that 5 meters from the camera we're going to start the mask, and then we're going to make it extend for 5 meters. So this value controls where the mask starts, and this value controls how far the mask extends. Then I'm going to saturate that just to make sure that it's going to be a value between 0 and 1. And then I'm going to invert it by using a 1- node. And I don't know if you noticed before, but my mask was going from black to white, and this will change it so that it's going from white to black. So let's go ahead and plug this into the color just to see what we're getting. And now you can see I'm getting a mask that near my camera is white, and then as it extends out into the distance, it turns black. And that's what I'm looking for, because I can use this map to determine where to apply my tessellation, or where I want to divide up the triangles versus not doing that anymore. Okay, and you can see that if I switch over to my wireframe, holy cow, I've got about 1 billion triangles going on right now. And that's because my default tessellation multiplier, I think, is 1. And so it's just tessellating everything everywhere. So I'm just going to go ahead and plug this into my tessellation multiplier, which means that I'm tessellating it close to the camera. And then as we get further away from the camera, we're going to stop tessellating it. So let's take a look and see what kind of a result this gives us. Alright, so you can see that near, close to the camera, I've got tons of triangles, lots of geometry to work with. And then as we get further away, the value just kind of fades out. And that's what we want, because we don't want to tessellate it way off here in the distance where it's not going to make any difference. We only want to tessellate it close to the camera where we're actually going to see it. That will save us some performance. If we're spending, thousands of triangles out in the distance, that's going to be killing our performance without actually giving us any good result. So what we've done so far is to create this mask that controls our tessellation multiplier, and so we only get triangles where we need them, close to the player, and further away from the player we can tone the triangles down so we're not tessellating out there. Okay, the next thing that we need to do is control our world displacement. And in order to do that, we need to know 2 things. We need to know how high to displace and what direction to displace in. And so for our height, we can use the height map of our textures. And you can see that I've got 6 different materials coming in here. And each of them has a height pin. And in previous videos, we created these materials. So if you haven't watched my previous episodes yet, be sure to go back and take a look at those to see how we set these materials up. And so you can get access to this height data. So to begin with, we're going to just use the height data from our river stones. And then a little bit later on, we'll grab all of the height data and blend it together. So first, I'm just going to grab the height from river stones, and I'm going to come down here and saturate that just to make sure that that value is always between 0 and 1. Now we want to push the triangles of our landscape up and down. So wherever our height data is 0.5, we're going to leave that as it is. But if it's above 0.5, we're going to push the triangles up. And if it's below 0.5, we're going to push them down. And in order to be able to do that, we need a lerp node. So I'm just going to bring out linear interpolate. And we're going to plug our height map data into the alpha value. Now, where the value is lower than 0.5, we want to make our height negative. So I'm going to multiply our height value here by -1. which will make it a negative value, and I'm going to plug that into the A of my lerp. And then I'm going to plug the regular height value into the B of the lerp. Actually, I'm completely mistaken. I actually need a multiplier, so for now I'm just going to add a constant, and I'm going to give this a value of 4, and this is 4 centimeters. So we're going to take 4 centimeters multiplied by -1, and 4 centimeters not multiplied by -1. And so our lerp is now lerping between -4 and +4 based on our height. So if our height is black, we're going to have a value of -4. And if our height is white, we're going to have a value of 4. So that gives our displacement a range between -4 and +4, or a total of 8 centimeters that we can displace. Now we also need to know a direction to displace, and for that we can use the vertex normal. So I'm going to bring in my vertex normal, and we're going to multiply the vertex normal by our height map. And now I can use this value to determine what direction I want to displace the vertices. So let's go ahead and save this, and we'll take a look at our result. Okay, so now on my landscape you can see that instead of being completely uniform, I've got displacement going on. So in the direction of the vert normal, I'm pushing the vertices up or down depending on the value that I'm using in the height map. This is pretty cool. Let's take a look at what it looks like when it's lit. And you can see I'm still using my mask data for color, so that looks kind of goofy. But you can see that there is quite a bit more detail and bumpiness happening here, and I really like what that's doing. I'm just going to go ahead and come back in here and switch my base color over to the actual base color instead of plugging my mask in. Alright, so now you can see I've got some landscape displacement, and it looks really cool. But it's only actually accurate for this rock material because I'm using the height map for the rock. You can see that my height map doesn't really match up to this wet-looking moss or any of the other materials because I'm only using the height map from the rock. The other thing that we notice is as we move away, there's kind of this line where you can see right here, as we move closer, it's kind of bubbly. And there is something that we can do to help with that. If we multiply the amount of displacement that we're doing by the mask that we created for the tessellation, it'll work to kind of soften that line. So let's do that next. So here's the amount of height displacement that we're doing. And here's the normal that we're using for offsetting the displacement. And then here's the mask that we're generating. And we want to take the result of this value and we want to multiply it by our height. And what this will do is off in the distance, our height will shrink and it will kind of soften the amount of bubbliness we get where the displacement is stopping. Alright, so now as we move around, you should see that there is significantly less bubbliness happening, and I've kind of eliminated that that artifact because the height slowly increases in the distance instead of having a really fast cutoff like it was before. If we switch to our wireframe view, you can see that our tessellation is disappearing in the distance, and then we slowly increase the height so that we get good results up close without too bad of an artifact in the distance where our extra tessellation is going away right there. Okay, now one last thing that I want to do before we get into using the heights from all of our different materials is I kind of have a bit of a mess here, and I really like to keep things clean. And so what I'm going to do instead of using all of this mess, is I'm going to go ahead and convert this into a material function and use that material function in my material instead of all these individual nodes, because this generating the world displacement and tessellation multiplier is something that I know I'm going to want to do a lot, and so I'm going to go ahead and create this into a function so that I can use it over and over. And so here's the function that I've created. You can see that I have my height multiplier, and I have an input for my height value that's going to come from the height maps from my materials. And then I'm saturating it, and I'm going to -4 and +4, which means I have a range of 8 centimeters between 0 and positive, between -1 and 1. And then I have my vertex normal that I'm multiplying by my height value, and also multiplied by my camera distance value. And then I'm outputting those as world displacement and tessellation multiplier. So I went ahead and brought in my landscape displacement node, which is basically the same as all of these. And I can take the height value that I was using, and from that height I get world displacement, and I also get my tessellation multiplier. And now, instead of using all of these nodes, I can just delete these and use this one instead. And that keeps my graph nice and clean. All right, let's save it and just check and make sure we didn't make any mistakes. We're going to switch back here to our map and wait for our shaders to compile. And you can see that the function, the material function, is doing the exact same thing as all those individual shader nodes were doing, but now we have a much cleaner graph. All right, we're making some really good progress. The last thing that we need to do is actually use the height data from each of the individual materials. And in order to do that, we're going to need to blend between each of them using lerp nodes. So I'm just going to go ahead and create a bunch of lerp nodes for myself. So we're going to blend between the height of river stones and mossy stones. And then we're going to take the result of that and lerp between that and our mossy ground. And then we're going to lerp between that and our moist stone. And we're just going to keep on doing this. So now you can see I've got a nice chain of lerps where each of these values is plugging into the next one, and I'm just continuing to blend the height of each individual layer. Okay, now the next thing that I need is a value to use for alpha to be able to blend between each of the individual layers. And how can I do that? Well, there's a node that's called Landscape Layer Sample. And what this node does is it brings in the mask that I've painted for each individual layer when I painted the materials down. And it allows me to blend from one layer to another. And so for the sample, can you see here how it says none? What I need to do is give it the name of each of the layers that I want to use. So this would be mossy stone to use the same layer name that I'm using here. And it's going to use that name to know which data to bring in. So I'm going to use my mossy stone layer to blend between river stones and mossy stones. So I'm going to make another one of these. And for this one, I want mossy ground. Okay, so now I'm blending between each of my height map layers, and I'm using the mask that I painted for applying those materials to each of them. And then at the end of my lerp chain, I can now take this value and pass it into my height map. So that's going to take the height from all of my individual material layers, blended correctly with the layer masks, pass it into the height, and then use that height to calculate the correct tessellation and world displacement. So I'll save it and switch back over to my mask or my map and wait for my shaders to compile. And when we're all done, we end up with something that looks like this. So you can see that as I'm kind of far away from my terrain, there isn't any displacement because of that mask that I'm using, but as I get close, the terrain gets tessellated, and I can see that the shape of my terrain is a lot more realistic looking. So this is really cool. I love what this looks like. Now, one thing that I will mention is this doesn't come for free. It's kind of an expensive technique. You can imagine that looking at this number of triangles that it's pretty heavy. There is a little bit of tweaking that you can do. If you work in your landscape displacement material and you adjust these values so that they happen closer to the camera, you'll end up with fewer triangles, and that will make it a little cheaper. But what you're going to need to do is measure the performance that you get before adding displacement and measure the performance after, and determine if that cost is actually something that you want and if it's worth the quality improvement that you're getting. This is probably something that you can do on like high-end game consoles and PCs with strong graphics cards. But if you're using a PC with kind of a medium to weak graphics card, or especially on mobile, this technique is just completely off the table. This is something that you can do on, medium to high-end PCs and really nice video game consoles, but for lower power platforms, you definitely don't want to use displacement. All right, let's go ahead and hit our play button and just run around with our character and take a look at our final results. So you can see that the landscape displacement is giving us much more realistic looking shapes here in the foreground. The terrain or the landscape actually feels like it has little rocks and pebbles and cobblestones and moss on it, as opposed to just being textured with a flat undetailed material. I really like what displacement does, and it's something that I will leave in my project, and I'll probably want to sacrifice something else in order to have displacement. And that means that maybe I don't have as many bushes or trees or something in my scene, and that will allow me to do displacement up close so that I can get this look of the terrain that just looks significantly more realistic. Anyway, I hope you've enjoyed today's tutorial. The next thing that we're going to take a look at is starting to add rocks and trees to our scene. So next week, I hope you come back for that one. We're going to take a look at selecting some rocks and trees from the Unreal Marketplace. And we're only going to use assets that are free, and we'll download them and get them ready to add to our scene. So be sure to come back next week. And if you haven't already, go ahead and subscribe to the channel, and I'll see you in next week's video, everybody. Thanks a lot.